Hey guys, and welcome back to this video by the artist formerly known as Turdferg67, i.e. Mr. Cole to all the beloved fans out there. Alright, so in this video, getting us back together, last video, here, I'll just show it, what we did in the last video. As soon as my thing actually does, come on, click. We did a problem where we had a horizontal component. And I said last time, that one's always the easiest just from a mathematical standpoint. So how do you solve a problem where it's like this one and you've got both cables are at an angle? How do you solve this one? All right, so that's what we're going to do in this one. First thing we need to do before we go any further, let's see if we can't draw a decent free body diagram of this. So start off by getting do a little set of crosshairs here. And then if I was good, I'd just be using my arrow keys, but hey, you may be working this on paper. So if we look, we have what we have. We had a T2 to the right, and the problem defined that for us at an angle of 53. Now, here's the thing. Hopefully you got this. If this angle up here is 53 degrees, then that means this angle is 53 as well. And likewise, on the other side, if that angle appears 37, then this angle is also 37. And so again, it defined it. And so let's go ahead and do this. We'll stick to what they did. So our free body diagram, we've got a T2 up and to the right of 53 degrees. We'll define that as T2. Your teacher may want you to put the little vector signs over that. Hey, that's cool. I like it. It looks good if you do that. Usually not a prereq in like Physics 1, algebra based. T1 is, well, we don't know what that is either, but we've got a 37-degree angle on this side. And let's use that same 100 Newton stoplight as before, and we'll define mg as 100, or again, depending on your teacher, fg. Your teacher may want the little arrow above it. Your teacher may want you to write fw. Your teacher may want you to write w. All of the above are correct responses to what is pulling that light down. All right, so again, this problem is really as simple as doing a sum of the forces x and a sum of the forces y. So typically, unless it's moving, this is going to be positive for me on x and positive for me on y is going to be up. So let's do x first. So we immediately look, anything with a component pointing towards the right. Well, this T2 has two components. It has a positive y and a positive x component. So I'm going to write T2, what have we got? T2 cosine of 53. And again, if you're a little weak on the algebra of this, I've got a separate video I'll link down at the bottom to help you get your algebra up a little. So now that we've addressed what's pointing right, we say, well, is anything pointing anywhere to the left? That could be in any quadrant on this side. And yeah, we've got a T1, and we'll use cosine for this as well. So we're going to subtract that T1. What's that? Cosine of 37 degrees. And what makes this problem unique is the fact is that all the forces are balanced, and it's just sitting there chilling. Now, sum of the forces y, same thing. We look for anything pointing up since I made that my positive direction. So I'm going to write T2 sine of 53 degrees. And then I look over here, and T1 is also has a positive upward component. So I'm going to write plus T1 sine of 37 degrees. And now we'll sit here and look and see if there is anything pointing down. And yeah, take a look. We've got this 100 newtons down. I'm just going to write minus 100. Now, if this was like a free response or some kind of derivation question, I might write mg or one of these, like if you're doing an AP question where there's no numbers involved. Your answer might be like T1 is equal to something in terms of mg. So here's what makes this one hard. We've got two unknowns, but the way the problem's set up is nothing just solves readily. So here's what we're going to do. I'm going to change to a color of blue to finish this. I always pick, when I've got to solve and substitute, I always pick the simpler of the two expressions to solve, which for this is the x. Let me give you one more advice too. When you're just double checking your physics on this, go through, because here's the thing, guys, the physics in this question's over. If you see a T2 cosine 53, then you need to be looking and see that you have a T2 sine 53, and likewise cosine 37 sine. Just make sure that's a little quick check. So here's what I'm going to do. I'm going to solve T2 cosine 53, and then I'm going to go ahead and do something. I'm going to go ahead and add T1 cosine 30 to the other side, so that I have T1 cosine of 37. Now, it doesn't matter how you do this, but we need to simplify. So I'm going to simplify for T2. So divide both sides by cosine of 53, divide by cosine of 53. Now let's go ahead and pull out that beautiful calculator. Well, this part will be easy, right? Cosine 53 over cosine 53. So cosine of 37 divided by cosine of 53, and we've got 1.32. That would be 1.32 T1. So let's rewrite it so it's a little bit clearer. T2 is equal to 1.32 T1. And now all we're going to do, we've solved for T2 as far as we can solve. Now we'll take that and substitute it back into our second equation. So that other equation, here's what we're going to do. In place of the T2 up here, T2 sine 53, I'm going to write 1.32 T1 times the sine of 53 plus T1 sine of 37. I'm going to go ahead and add 100 to both sides. Move it over. And let's grab a calculator. Again, the physics was over a long time ago. So 1.32 times the sine of 53. We've got 1.05, so this becomes 1.05 T1. Sine of 37, roll that beautiful footage, would you? Sine of 37 is 0.60, so plus 0.60 T1 equals, and guys, you should be good with this, but if you're not, you can finish it with me. So this would be added like terms, 1.65 T1 now equals 100. So just out of curiosity, 100 divided by 1.65 is 2,033. I knew it. 60.6 repeating, so T1 is 60.6 newtons. And then now if you want to find T2, let's go back. Give me a black, why not? If we want to find T2, all we have to do is bring this back, substitute in T1 for this, which will be 1.32 T1, and just out of my OCD, we'll do it just so I feel good about myself, times the answer equals 80. So T2 would be equal to 80. And this would be good in any class you were taking. The only difference, a teacher might put little arrows above these because they are vectors. But anyway, guys, 8 minutes. Hopefully now you feel a lot better about these kind of questions. I guess I ought to do one more question. We'll call it part 3. In part 3, we'll do this. Usually then you'll work a problem eventually where one of these angles is unknown and the math is a little bit more interesting. So anyway, guys, thanks for watching. Be sure to, do the like, do the comment, do the hang out with, Mr. Cole a little bit more. Later, dudes. Bye.